Hello guys, and welcome back to my YouTube channel on the Big Structure Hub. This is a place where you learn, build and innovate. Today I want to solve a problem from stability of a retaining wall, and it is example number 2. The question is from CDAC 2024, that is July-August. So the question is on the board and it reads, analyze the retaining wall shown below for overturning, sliding, and bearing of soil, given the factor of safety is 1.5. Also given that the angle of internal friction of the soil is 30 degrees, unit weight of soil is 18 kilonewton per meter cubic, coefficient of friction between soil and the concrete is equal to 0.6, allowable bearing capacity is equals to 180 kilonewton per meter cubic. Unit weight of concrete is equal to 24 kilonewton per meter cubic. So the question carries 20 marks, and it is a retaining wall with a surcharge. So what is a surcharge? A surcharge is an addition vertical loads or pressure that is applied above the retained soil behind the wall. So as you can see, this is a surcharge. It is on the top of this backfill, and it is 27.5 kilonewton per meter square. So the dimension of this retaining wall is 200 millimeter on top, and then the stem is 3670 millimeter, and then the thickness of the base is 330 millimeter. The toy is 1560 millimeter, and no, the heel is 1560 millimeter, and the toy is 810 millimeter. The bottom width is 330 millimeter. So let's see how you can solve such a question with a surcharge. So solution, the first thing to do is to draw the pressure diagram for the retained soil. So let's draw it here. So this is the pressure diagram for retained soil. So it is a triangle. So let's assume the pressure is acting at this point, and this is the active pressure. The active pressure is the pressure that will cause this retaining wall to overturn, and it is a pressure as a result of the retained soil. Like that. And remember, this pressure is acting at a height of h over 3, like that. So that is our active pressure, and the intensity of this pressure at the base is given by Ka times unit weight of the soil times H. So this is the pressure intensity at the bottom of this soil. We also have another pressure. And this pressure is as a result of this soil. So this one will be the passive pressure, and it will be pressure exerted on this side of the soil. So if you can draw, this is how it will look like. So that is the passive pressure, and this pressure, it helps in preventing this retaining wall from sliding. So that is P. And the intensity of this pressure at the base is given by Kp, unit weight of soil, times H, where Kp is the Rankins coefficient of passive pressure, and Ka, this Ka is the Rankins coefficient of active pressure. So after doing so, you can now start solving the equation, but we also have another pressure as a result of the backfill and the surcharge. So this is another pressure from the backfill of this retained soil. We also have another pressure from the ground, but this one we will draw it after calculating the minimum pressure and the maximum pressure exerted on the ground. So let's now begin by tackling this question. So solution. So in the question, we have been told to analyze the retaining wall shown below for overturning, sliding, and bearing of the soil. So I will start by overturning. So number one is overturning. So you know that this is the pressure, the active pressure that will cause this retaining wall to overturn, and it will overturn at point A. So the factor of safety for overturning is given by the resisting moment over overturning moment, and this should be greater than or equal to 1.5. If not so, it means the overturning will occur. So what is a resisting moment? So a resisting moment is the moment due to all vertical forces. So the vertical forces will be the force as a result of this retaining wall, and also the forces as a result of the backfill soil, and also the force as a result of the surcharge. And what is overturning moment? So this is the moment as a result of the active force or active pressure, which is Pa acting at a distance of h over 3. So allow me to clean here so that we can continue with our question. So let's begin by overturning moment. So overturning moment. Overturning moments. This is the moment due to horizontal force. And the horizontal force is Pa. And Pa, we know that Pa is given by W h square over 2 into bracket 1 minus sine phi over 1 plus sine phi. So this is the formula for Pa. So Pa is equal to WH square over 2 into bracket 1 minus sine phi over 1 plus sine phi. So in simple terms, Pa is the area of this pressure diagram. We know that the area is a half base times height. And as you can see, the base is Ka unit weight of soil times H, where Ka is the Rankine's coefficient of active pressure, which is this one in the bracket. And the H is the distance from here to the top. So let's continue. So Pa is equal to W is nothing else but the unit weight of the soil, which is 18 kilonewton per meter cubic. So it's 18 times H. So H, you will take 330 plus 3670, which is 4,000 millimeter. We convert it to meters. So that is 4. You divide by 1,000 over 2 into bracket 1 minus sine 30 all over 1 plus sine 30. So if you carry out the operation, you will get 48 kilonewton. So 48 kilonewton, and it is acting at a distance of h over 3, so which is 4 over 3 from the base. After calculating the Pa, now we will calculate the overturning moment. So the overturning moment is equal to Pa times the perpendicular distance is h over 3, like that. So therefore, it will be 48 times 4 over 3. Then we'll get our overturning moment as 64 kilonewton meter. So that is our overturning moment. From there, we proceed to resisting moment. So I will clean also so that you can have space for more calculation. So we proceed to resisting moment. So resisting moment is moment due to all vertical forces. So the first thing to do is to calculate the vertical forces. So let's calculate the vertical forces. So vertical forces. So what we will do, I want to divide this retaining wall. As you can see, this is a trapezium, but I want to divide this trapezium into a triangle and a rectangle so that I may end up having something like this. Yes, like that. So this is a triangle, no, a rectangle, and this is a triangle. And you know that this is a stem. So we'll call this as stem 1 and this stem 2. And then you have the base. So the base is made up of the toe, the heel, and the bottom of this stem. So I will call the base number 3, like that. So I will start calculating the forces as per the shape of the retaining wall. So let's begin by force in stem 1. So force, or we can just say stem 1 force. Stem 1 force. So to get the force, we'll first calculate the area of this stem number 1, and then we will multiply it by the unit weight of the concrete. So the area is length times width, so that is 200 over 1000. We are changing it to meters. Then times the length or the height of the stem is 3670 over 1000. Then times the unit weight of concrete you have been given as 24. If you multiply, you will get 17.6 kilonewton. We proceed to stem 2 force. So stem 2 force will be the area of this triangle times the unit weight of concrete. So this one will be, so we will first get this distance from here to here. So you'll take 330 minus 200. So you will get 130. So this is 130 from here to here. So the force of stem 2 will be a half times 130 over 1000, then times the height is 3670 over 1000 times 24. So if you carry out the operation, you will get 5.73 kilonewton. We proceed to the base, which is number 3. So base, which is 3, force. So this one is the area of the base times the unit weight of the concrete. So the area is equal to, that is length times width. So 810 plus 330 plus 1560, you get 2700. So 2700 over 1000 times the thickness is 330 over 1000 times 24. So if you carry out the operation, you will get 21.38. We proceed to the force as a result of the backfill. So as a result of the backfill, it will be the area, it will be this area times the unit weight of the soil. So that is it. So that area, we have 1560 times 3670. So we have 1560 over 1000 times 3670 over 1000, then times the unit weight of the soil, which is 18. So you will get 103.05. We also have a vertical force as a result of the surcharge. So this is the surcharge. So you will also calculate the vertical force of the surcharge. So we say surcharge. So the surcharge will be 27.5 times the length, which is 1560, 1.560. We convert it to meters. Yes, like that. So we will get 42.90 kilonewton. 42.90 kilonewton. And then we will get the total vertical force. So summation of vertical force is equal to, you'll take 17.6 plus 5.73 plus 21.38 plus 103.05 plus 42.90 76.90, and the total vertical force is 190.68 kilonewton. So that is the total vertical force. After doing so, we now proceed to moment as a result of this vertical force. So allow me to erase here. So we are now calculating the resisting moment. So the resisting moment. So resisting moment is moment due to all vertical forces, and moment will be given by equals to force times lever arm. So let's start calculating our moment. So we'll start by moment as a result of stem 1. So as a result of stem 1, it will be force of stem 1 times the lever arm. So we know that the force of stem 1 was 17.62 times the lever arm. So let me show you how we calculate the lever arm. So the lever arm is the distance from this point of our turning, which is point A, to the middle of the stem 1. So this is it. So it's this distance from point A to the middle of stem 1. So it is 810 plus 130 plus 100, because a half of 200 is 100. So times 810, 0.81 plus 0.13 plus 0.2 over 2. So you convert it to meters. So you will get 18.32. So you will get 18.32 kilonewton meter. So that is moment of stem 1. We now proceed to stem 2. So for stem 2, it will be the force of stem 2 times lever arm. So this is stem 1. So the force of stem 2 is 5.73. Then times the lever arm. So I want to show you how we will obtain the lever arm for stem 2. So for stem 2, it will be this distance. So this is stem 2. So it will be the distance from point A to the center of this stem 2. So this distance is given by, as you can see, 0.81 plus 2/3 times 0.13. That is the centroid of this stem 2 as you proceed from this point, like that. So if you carry out the operation, you will get the moment is 5.14, so which is equal to 5.14 kilonewton meter. We now proceed to number 3, which is the base. So this is number 3, which is the base. So that one will be force of base, which is 3 times the lever arm. So force of base 3 is 21.38 times the lever arm. So the lever arm, it will be this distance, 810 plus 330 plus 1560, and then you divide by 2. So that is 2.7 divided by 2. So the answer will be 28.86 kilonewton meter. So that is for base 3. We now proceed to the backfill. So it will be force of backfill, times lever arm. So the force of backfill is 103.05. So 103.05 times the lever arm. So the lever arm will be this distance starting from A to the center of. So we start from A to the center of the backfill distance. So that is 810 plus 330 plus 1560/2. So 0.81 plus 0.33 plus 1.56/2. So you will get 197.86 kilonewton meter. And then you go to the surcharge. So surcharge, so this one will be the force of surcharge, which is 42.90, then times the lever arm, which will be the same as that of the backfill. So times 0.81 plus 0.33 plus 1.56 over 2. So you will get 82.37 kilonewton meter. And then we will obtain the total resisting moment. Total resisting moment. So you will add this plus this plus this plus this plus this. And the total moment is 332.55 kilonewton meter. So now you can check the factor of safety for overturning. So factor of safety for overturning, since we have the overturning moment and the resisting moment. So factor of safety for overturning is given by 332.55. This is the resisting moment over the overturning moment, which is 64, and it should be greater than or equal to 1.5. Yes, 1.5. So if you punch the calculator or carry out the operation, you will get 5.2, which is greater than 1.5. So therefore, okay, in overturning, so no overturning will occur. So the retaining wall is safe against overturning. So safe against overturning. Like that. Now we check for sliding. We now check for sliding. So let's check for sliding. So factor of safety for sliding is equal to resisting force over sliding force. And resisting force is given by mu times summation of vertical forces plus passive pressure. So this one mu times summation of vertical forces is equal to 0.6. So 0.6 is in the question as coefficient of friction between the concrete and the soil, and then times the vertical forces. Summation of vertical forces is 190.68. So you will get 114.408. And then the passive pressure is given by WH square over 2 into bracket 1 plus sine phi over 1 minus sine phi. So in simple terms, the passive pressure is the area of this triangle, which is as a result of the pressure, passive pressure. So this one is equal to W is the unit weight of the soil, which is 18 times H. H is this distance from here to here, which is 330. So 330 over 1000 square over 2 into bracket 1 plus sine 30 over 1 minus sine 30. Then you carry out the operation. So if you carry out the operation, your answer will be 2.94. 2.94. So let's get the total resisting force. So resisting force is equal to 114.408 plus 2.94, and you will get 117.35 kilonewton. So that is our resisting force. And we know that the sliding force is this force caused by the active pressure so the sliding force is equal to PA, which is equal to 48 kilonewton. So factor of safety for sliding is equal to 117.35 over 48. So the answer is, and this one should be greater than or equal to 1.5. So our answer is 2.4, which is greater than 1.5. Therefore, no sliding will occur. We are done with the sliding. We now proceed to bearing capacity. So I now proceed to bearing capacity. So bearing capacity for bearing capacity, you know that P maximum is given by summation of vertical forces over B1 plus 6E over B. So whereby E is equal to B over 2 minus D. So if I can draw the base, of this retaining wall, and that is the center, so this is the point where the resultant cuts the base. So this will be the E, and and this one will be D, like that. So now we are supposed to get this D so that it can help us to calculate E, and this is B over 2. So this is B over 2. So D is given by moment of resistance minus overturning moment over summation of vertical forces. So we have already calculated our moment of resistance and our overturning moment. So D is equal to 332.55 minus moment of resistance is 64 over summation of vertical forces is 190.68. So which imply D is equal to 1.41 meters. And we know that this R should be lie within the middle third rule. So we are supposed to check if it is within or not. And to check, we will first obtain our E. So our E is equal to 2.7 over 2 minus 1.41. So which is equal to minus 0.06 meters. Minus 0.06 meters. So let's check. So to check whether this R is within the middle third rule or not, we'll use this expression E should be less or equal to B over 6. Which imply E is negative 0.06 is less 2.7 over 6. So this distance from here to here is 2.7, which is from here to here. So it therefore implies that minus 0.06 is less than 0.45. Therefore, our resultant R lies within the middle third rule. So therefore R is in the middle third rule, like that. Now we know that this is the formula for getting maximum pressure, which is summation of vertical forces over B into bracket 1 plus 6E over B. But it only applies when E is positive. When E is positive. But when E is negative, it means this formula will give us pressure minimum. But when E is negative, our pressure maximum will be calculated using this formula. So here it changes to negative, the other way around. So P maximum is given by summation of vertical forces. So P maximum is given by 190.68 over 2.7, then into bracket 1 minus another bracket 6 times negative 0.06 over 2.7. So you will get 80.04, and which is less than 180 kilonewton per meter square. So this 180 is the safe bearing capacity of the soil, therefore okay in bearing. And then we proceed to P minimum. P minimum will be given by this formula, summation of vertical forces over B into bracket 1 plus 6E over B. So if we can insert these values into the formula, this is what we'll have, and therefore our answer will be 61.21, which is greater than 0 but less than 180 kilonewton per meter square. 180 is the safe bearing capacity of the soil, and that marks the end of that question. Again, we can draw the ground bearing capacity. So using 80.04 and 61.21. So this is how it will look like. So at A, we will have 61.21, and here is 80.04, which is at B here. So that is where we have our maximum pressure. So that is how it will look like. So this is 80.04, which is greater than 0. And here we have our P minimum as 61.21, which is less than 180. And that is it. So that marks the ends of that question.